All right, so what we're going to talk about, and actually before I show you in behavior, let me talk to you just a minute, because we're still analyzing these polynomials, okay? We've got a few more things to do with the polynomials. Yesterday we talked about type, leading coefficient, constant, degree, maxes, mins, zeros, y-intercepts. So today I want to talk to you about what if I'm given something like this. Now, I can easily graph that, okay? There's nothing wrong with the, yeah, if you want to move over, you can, I'm sorry. There's nothing wrong with the form that it's in. But if I need the leading coefficient and the type and the constant, I can't get it the way it sits, okay? So what I need is I need to expand that out. So to expand it out, and you're going to have at least 2 on your test that you're going to have to do this with before you can finish analyzing, okay? So this goes back to the test you just took. How do I expand that out? What do I do? How do I multiply that? 2 at a time. So I'm going to FOIL the first 2. So x times x is x squared. There you go. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. So I got x squared plus 4x plus 4. And now I still have this x plus 1. Okay, so now I can take it to that third. So x squared times x is x to the third. Y'all are mighty quiet today. X squared times 1? 4x times x? 4x squared. 4x times 1? 4 times x? X. And 4 times 1? 4. So let's combine like terms. So now when you look at this, now you can easily find the leading coefficient, the constant, and the degree. What's the leading coefficient? 1. How do you know it's 1, Jordan?
Because x to the third has the greatest exponent and there's an assumed 1.
Exactly. There's an understood 1 in front there. So my leading coefficient is 1. How about my constant? 4. That's the one without a variable. And how about the degree? 3. And what about the type? Cubic. Good job. Degree is 3. Type is cubic. Okay, so realize that I couldn't have gotten this information without doing this first, and you'll have a couple like that. And I wanted to show you that.
So we're not going to have to do the graphs, or we're not going to have to do it yesterday.
We will, but there'll be a couple of them that the initial equation will be given to you like this.
And solve it out.
So you'd have to, right, you'd have to expand it out so that you could get this part of the analysis. Behavior. In behavior is what we use to describe both ends of the graph. Okay, since it has 2 ends, there's 2 parts. So this is a little bit different than what we've been doing, and it's the reason that I saved this all by itself for the second day, is because it's a little confusing. So we use some mathematical language here to do this. All right, I'm going to start with the example of a graph. What kind of graph is that?
That's a cubic graph.
That's a cubic. Good job, guys.
Yeah.
All right. So, and let me put my x and y axis on here. This is my x axis. This is my y axis. Yes?
See.
And if I asked you in which direction x gets bigger, what would you tell me? To the right. Okay. This is x getting bigger this way, right?
Well, it has to be bigger again.
Because this is x is 1, 2, 3, 4. It's getting bigger the further right I go. Right?
Yeah.
So then it's getting smaller the further left I go.
But it goes further down when you
Mm-hmm.
I don't understand.
It goes what now?
The graph goes.
Okay, but that has to do with the y and not the x. And we're not looking at the graph, the blue so much right now, is I just want you to understand when I say a really, really big X, I'm talking about look to the right side.
Gotcha.
Okay? If I say find me a really, really big Y, I'm talking about look up, right? So the bigger Y gets, I'm talking about up. Bigger. Up. And then, of course, small y would be down. All right. So how many ends do you see on this graph?
Wait, how many what?
How many ends does it have?
Two.
Two. Does everybody agree there's two ends?
Two arrows.
And what
Okay.
you say on the bottom right there?
Small y goes down. This is an end, and this is an end, right? All right. I'm going to use some mathematical terminology here. I'm going to call this end number 1, and I'm going to call this end number 2. Okay? For end number 1, I'm going to say, as x, and now I'm going to use this mathematical symbol. So this little arrow here, and what that arrow means is
Bigger.
approaches, gets close to, goes towards. As x approaches, what does that symbol mean? Plus what? Infinity. What is infinity?
Forever.
Forever. Really, really, really big, right? Plus, positive infinity is really big, yes? Do we agree? Where is x really big?
Infinity.
Where is x really big, graphically?
I don't know.
The right side, right?
Oh.
As we move right. Okay, so that tells me I'm describing end number 1. As x gets really big, what does y do? In other words, does y get really big or really small?
Small.
Why?
Because X is getting bigger.
It's going down.
Big.
The graph is going down. This says, so I do negative infinity. This literally says, if you were to interpret this, this would say, as, actually no, it would say the right side goes down. Right meaning x is big, down meaning y is negative.
Are we talking about like the line of stuff?
We're talking about the blue graph.
Okay, so as that blue line goes further x, it's going
Further down, right. The further you go right, the further the blue line goes
If you go
down.
left, it's going up.
Exactly, Brady. So if I do as x goes negative infinity, so this time if I look at the left side of the graph, is the left side going up or down? Up. So up is y to positive infinity.
Just say that one.
Nah, it's not easy. It's just kind of
Okay, so let me give you another graph and let's see if you can describe the end behavior.
You gotta do the same thing you just did.
Mm-hmm.
Isn't there only like 2 options you can do?
Oh,
What kind of graph is that?
quadric.
A close, a quartic. Quartic.
He said.
So the thing with end behavior is that it's always going to be the same starting 2 sentences. As x goes positive, what does y do? And then as x goes negative, what does y do?
Alright, there's 2 endings.
There's 2 ends. There's always 2 ends to a graph.
Yeah, ending.
Alright, number 1.
And then, alright, as X.
Those ends are always a left end and a right end. Yes? Does that make sense to everybody?
Left end and the right end.
A left end and a right end. All right. So the first one is asking me to look at which end, the right or the left?
Right.
The right. So on the right side, is the graph going up or is the graph going down?
Oh, so they need to go,
It was probably.
Yes.
yeah.
You're gonna be working on infinity, right? You're gonna be only for this.
Only for this.
That's a hard thing to
So if it's going up,
Infinity?
yeah, like as a value.
Yes, it is.
So then y is, no bigger.
Which way? Look at the left side. Is the left side of the graph going up or is it going
Oh,
down?
Oh, so it's bigger, so it's plus.
wow, you tried tricking us.
There's 4 possibilities.
Let's go to class where I'm ready.
We're going to make a chart. Okay? I want you, this is recognizing it graphically, but I also want you to be able to use this chart, and you'll be able to use this on your test. I want you to have this that you can use that will help you verify what you're doing, okay?
I need one of those.
Oh, pass that back, please, Johnny. All right, let's do this. Let's make 4 squares out of this, okay? So take your paper.
Ow.
How? Oh, my
You need a
goodness.
hot dog or hamburger first?
Both.
Which one first?
Doesn't matter.
I got a crease in my paper, I can tell.
Well, so you're telling me if I don't do exactly what you're doing from here, I'll hold it together.
Yeah.
I'm
You fold it
confused.
long ways and then short ways, or short ways and long ways?
Okay, what if you do it long ways and,
I got one, I was
Were you
like,
about to say long ways and long
Yeah.
ways?
so does it matter?
Let's not make this the ordeal that was the last foldable we did, please.
Alright,
Well, I don't know
so,
what you did.
so which way did you go first?
I want 4 even squares on my orange sheet of paper.
Did you go long ways first? Or did you go?
Either way's fine to go first.
Alright,
man, where the
This is what it should look like.
Does this look right?
Hey, Chuck, you I gave you my money.
We're gonna set up our chart so that we have all 4 scenarios in here. So for each square, I want you to write the following. We're gonna base this on the leading coefficient and the degree. So leading coefficient, oh, I need a skinnier color than that.
What's wrong with that one?
Well, I'm not gonna have room to write what I need to. Leading coefficient
You write down small.
and degree. No. You're gonna need room here to write the 2 lines of in behavior under it. So each square is gonna get headed with leading coefficient and degree. All right, we're going to look at 4 different scenarios. The leading coefficient, that's my A in the front that causes it to flip up or down, right, Brady? So I'm going to look at that being positive. So you need 2 positive leading coefficient squares and then 2 negative leading coefficient squares. You'll see where we're going with this. Negative. And then the degree, what I want to do, I want to look at it as if it's an even degree or an odd degree. And the reason is when we start talking about even degrees, both of the ends go the same way. And odd degrees have ends that go opposite ways. So I'm going to look at even versus odd, even versus odd. Now what's neat about in behavior is that no matter where I go, no matter what my equation is, if it has this qualification, then the in behavior is going to be the same. So if it's a positive odd, then it's all positive odds have the same in behavior. Okay?
What's that mean?
It means, like if I have an even degreed positive, so maybe like a quadratic that opens up. Both ends go the same way. So the end behavior for every one of these is going to be as x approaches positive infinity, which means look to the right. On the right side, the graph's going to go up. And on the left side, the graph is going to go up. Both ends go up, no matter if you're on the left or the right. Actually, let's go down and let's look at this one. I'm talking about something like a quadratic that goes down. Both ends in this case are going to go down. So if I'm on the right side, I'm going down. And if I'm on the left side, I am going down. Now let's look at the odd degrees. So these would be like cubics or lines. Okay, so positive leading coefficient would look something like this, a line with a positive slope. Okay, so on the right side, which way am I going? Up. And how about the left side? Negative. These, any odd degree is always going to be opposite. Okay, it'll have one positive, one negative. Very last one is going to look like a line with a negative slope. And this is not the only, I'm just picking one graph that would meet these requirements, because if I can figure out the end behavior of one, I know the end behavior of all of them like that are the same. So this time, what's the right end do? As x approaches positive infinity, y goes down. How about when x approaches negative infinity? It goes up. Hey, Jalen. Does that make sense?
Yeah.
You need that for pre-cal? Let's see.
I saw that.
What?
I said a funny video somebody.
No.
He was a beauty hit by a car.
Example. Let's say.
Oh, we do that on paper.
Do what?
Do it on paper?
No, we're going to use that paper to do the end behavior.
This on our windshield.
Wait, do we still have to do all that other nonsense we did yesterday? Or like,
No, do this on a separate paper. Yes, we do. Full analysis. Now, in addition to all this, we got end behavior. All right.
So,
Look at this one.
this is the 50.
Oh my goodness, it's a 15th degree. That's going to be a lot to graph. But right now, what I really want to focus on is what are the ends going to look like? Are they going to go up and down and up, both down? So all you have to do is take your chart. Okay, let's look, what's the degree?
15.
15. Is 15 an even number or an odd number? It's an odd number.
X is negative.
The leading coefficient is what?
Negative.
Negative. So I'm going to the square that is odd and negative. Okay? Odd and negative.
the positive.
Odd and negative. So I'm in the bottom right square. Yes? So this is the end behavior.
That's all I have to do, right?
So the end behavior is as x approaches positive infinity, y approaches, what did it say?
So we're looking at the.
Negative.
So we're
Yep.
looking at the leading.
The leading coefficient and the degree. So, and then I copy both of them because how many ends does a graph have? Two. So I copy both of them and this is my end behavior.
So we just do that.
Okay? Yeah, that's why I want you to be able to recognize it, like if you look at it graphically, but I want you to have this too. Some people are more visual, some people are more...
So we can use this thing on our test.
All right, so understand, I want you to understand what this means. This means I don't know what's happening in the middle of the graph, but I know the right side is going up and the left side, oh, just kidding. Gosh, Stacy, get it right. The right side is going down, the left side is going up. So it could be doing all kinds of stuff in between, but at the ends, that's what's happening. Does that make sense to you?
Yeah.
Okay.
I know it.